Hello everyone, and welcome to section 9.4, which is all about ellipses. Ellipses sort of look like an oval, so that would be like a horizontal ellipse. This would be like a vertical ellipse. So whether it's horizontal or vertical just tells us which end of it's longer. So this one's longer horizontally, so it's a horizontal. The other one is longer vertically, so it's a vertical. The way you can tell from an equation whether you are vertical or horizontal is based off of where your A value is. So A is always going to be larger than B. So whichever one of these, X or Y, has a bigger number underneath it, that tells you whether or not you're horizontal or vertical. So like in this top one, whatever A is, that's bigger than B, so my bigger number is underneath X. So bigger numbers underneath X, so I'm horizontal. That also means my vertices are X values. That also means my foci are X values. Foci are going to be sort of like a little bit to the left and right toward the center of the ellipse from our vertices. And co-vertices are the sort of like helping out, but they're the shorter ones, the ones that are a little bit closer to the center, which for us is going to be 0, 0. A very key relationship between A, B, and C, other than the fact that A is bigger than B is just bigger than C, is the fact that C squared equals A squared minus B squared. So if given two of the pieces of information, maybe you know how far away the focus is, and you know how far away the co-vertices are, you can figure out where the vertices are, and any sort of combination of those. So that C squared equals A squared minus B squared is very important. We're going to see a similar relationship with hyperbolas, but there's going to be one distinct difference. All of these conic things are just some sort of slice of a cone. For an ellipse, it's a diagonal slice. So here's just another visual of what these look like. So if I have a vertical, it's going to be taller. If I have a horizontal, it's going to be wider. And then vocab terms I won't really use on like your quiz or anything like that are transverse and conjugate. Sometimes, if it comes up in the ACT or anywhere else, it just might be good to know that the major axis is sometimes called the transverse axis, and the minor axis is sometimes called the conjugate axis. Again, I'll stick with major and minor, but in case you're reading something somewhere or it comes up anywhere, there you'll have it. So let's go ahead and write an equation from a graph. So I see it looks like it might be a little bit taller than it is wide. So let's count our units. So vertically from my origin, I'm going 1, 2, 3, 4, 5. So this distance is 5. Horizontally, my distance is 1, 2, 3. So I am indeed taller. That means my x squared is going to have the smaller number, and my y squared is going to have the bigger number because it's longer in the y-axis. So you can always set up exactly the structure that you know is going to be true. We know it's going to be x squared over something plus y squared over something equals 1. These always have to be equal to 1 in standard form. Otherwise, you have to divide by whatever number is there to make it equal to 1. So I take my distance from my center to my vertex, which is 5, square it, because it's a squared, so I've got 25. Take my distance from my center to my co-vertex, which is 3, square it, which is 9, and that's my equation for this ellipse. The larger numbers underneath the y squared, I know that I have a longer y-axis. My transverse axis is the y-axis and not on the x-axis. If I was going to be graphing an equation, so the reverse of what we just did, we're also going to have to identify the vertices, co-vertices, and foci. So let's take a look. So in this equation, my x value is larger. Therefore, it's going to be definitely a horizontal ellipse. So my vertices are going to also follow and be x values. Co-vertices will be y values. And then foci follow along with the vertices and those are going to be also x values. So let's see what we've got. So if this is a squared, and if I want a, square root of 9 is 3. For my co-vertices, this is b squared. Square root of 4 is 2. So my two co-vertices are going to be at plus or minus 2 on the y-axis. And then my focus, I have to use that c squared equals a squared minus b squared relationship. So c squared equals a squared is 9, minus b squared is 4. These typically won't turn out nice. Like here, we're going to get c squared equals 5, so c equals square root of 5. You're not going to have to graph it, you're just going to have to identify it. You don't have to figure out, okay, where in the world is my square root of 5? Don't worry about it. Just tell me that in this case, your focus is at positive or negative square root of 5, and we're good. So, for my vertices, they're at positive negative 3 on the x-axis. Co-vertices are at positive negative 2 on the y-axis. Try not to make it look like a diamond, but if it does, I'll know what you mean. And that's our graph. Now in this next one, notice I'm not equal to 1. In order to be in standard form and everything to work out, I've got to be equal to 1. So if I divide everything by 49, since right now I'm equal to 49 instead of 1, I'll get x squared, I'll just leave it as over 1, you don't actually need the 1 there, plus y squared over 49 equals 1. Now I'm in standard form. Now I can figure out, okay, my vertical or horizontal, where are my vertices, co-vertices, and foci, and go ahead and graph. So my larger number underneath the y squared. This is definitely going to be a vertical parabola. So for my vertices, they're going to be y values since I'm vertical. Co-vertices therefore will be x values. And my foci will also be y values. So, a squared is 49. That means a square root of 49 is 7. Here my b is 1. Square root of 1 is just 1. So if you left it as a regular x squared and you didn't have the x squared over 1, just realize that x squared over 1 is the same thing as x squared. For my foci, I use that c squared equals a squared minus b squared relationship. So c squared equals 49 minus 1. Square root both sides. And my foci are at square root of 48. If you recognize that square root of 48 does have a perfect square in it, it's the square root of 16 and the square root of 3, and you wish to simplify it, that's fine. I don't mind. One way or the other. Again, you're not graphing these, so it's not the most important thing in the world, just so long as you have some sort of semblance of square root of 48. So if we're going to be graphing this graph is going by 3's, so here's about where 7 would be. And then 1. And we have our ellipse. Occasionally get problems like this. So we have a listener standing in an elliptical room that is 60 feet wide and 120 feet long. When a speaker stands at one focus and whispers, the best place for the listener to stand is at the other focus. These rooms actually do exist around several places around the world. One of them is actually at the Museum of Science and Industry, so next time you're there, check it out. So we're going to write an equation that models this ellipse, assuming the major axis is horizontal. So we know our bigger number is going to be underneath the x squared, and our center is at the origin, like we're working with anyway. So this we all know to be true. Let me draw this. So we've got 120 feet long, and then 60 feet wide. So my distance from my center to my vertex is 60, because the hole spans 120, so consider that like your diameter. My radius then would be 60. From my center to my co-vertex would be 30, because the whole thing's 60, so again, think of that as my diameter, and my radius would be 30. So I've got x squared, y squared. 60 squared gets me 3,600. 30 squared gives me 900. And that equation would model this room. And lastly, writing the equation based on information either shown in a graph or just told to you like this. So I see that my vertex is an x value, therefore I know it's got to be the bigger number underneath the x squared. So for all of these, I know the general form. I just have to figure out the missing information. So they tell me the vertex is 4, that means my a squared is 16. They tell me my co-vertex is at 2, so that means that squared is 4. That's my first equation. Similarly, here they tell me that my vertex is a y value, so my bigger number is going to go underneath y. So negative 3 squared is 9, and 2 squared is 4. Here it's a little different because they give me the vertex and the focus. If they give you the focus with the vertex or the co-vertex, you've got to find out what the other piece is. So remember, we're using that c squared equals a squared minus b squared. They tell me my vertex, so I know my a squared is 9. Focus, 1 squared is just 1. So I'm going to move over b squared, move over the 1. So b equals the square root of 8, which is 2 root 2. But since I want b squared anyway, I'm just going to worry about the fact that it's 8. So that's going to be a y value, since I have an x value of 3. So a squared is 9, b squared is 8, and this would be a horizontal, this one would be a vertical, and this one would also be horizontal. That's ellipses. We'll look at these a little bit more in class, and I'll see you then.